In this video, we're going to be solving rational equations. A rational equation is an equation that contains one or more rational expressions. So I've written a couple of examples of rational equations. All right, so let's solve the rational equations. Now, notice we have variables in the denominator. Remember, with a fraction, we do not want the denominator to be 0. So what value of p here would make the denominator 0? Well, that would have to be 0. Same thing for this p here. So we want to be able to write our restrictions first, because if we get an answer of p equal to 0, that is not going to be a solution here. Now, you don't like working with fractions, so we can use the least common denominator in order to get rid of all the fractions. Well, the LCD, well, between 4 and 8 is 8, but then we have a variable of p in the denominator, so we want to include that. So I want to multiply every single term by 8p. The p's divide out. 8 times 8 is 64. 4p divides out, so I'm left with 2 times 1, that's 2. The 8's divide out, p times 11 is 11p. Now notice, when we multiply by the LCD, there's no more fractions. So this equation gets a whole heck of a lot easier to solve for. 64 plus 2 is 66. That equals 11p. Divide by 11, and p is 6. So let's check to make sure that that is an acceptable solution. So every time I see a p, I'm going to replace it with 6. 4 times 6 is 24. LCD for everything is 24. And 32 24ths plus 1 24th is 33 24ths. They are the same, so I know 6 is the solution set here. Okay, let's take a look at another example. So again, you have a variable in the denominator. What value of x would make that denominator 0? Well, in this case, it would be 0 because 6 times 0 is 0. So again, in this case, I don't want x to be 0. All right, now let's get rid of the fraction. Well, there's only one denominator in this case, and it's 6x. So that's what we're going to do. We're going to multiply both sides by 6x. On the left, we have 6x squared. On the right, they divide out. That equals 6 minus 5x. This is a quadratic equation, so I'm going to set it equal to 0. So I'm going to add the 5x. And then subtract 6. Okay, so there's no greatest common factor I can take out other than 1. So remember how we factor these. Factors of negative 36, whose sum is 5. In this case, that's 9 and negative 4. So rewrite the middle term as 9x minus 4x. And then factor by grouping. So I'll group them here and here. So I can factor out a 3x. Here I can factor out a negative 2. Factor again. And then set each factor equal to 0. So our solutions are negative 3/2 and 2/3. Now, I will not check it in this video, but you will want to go back and verify that both of these are solutions to this equation. Okay, so to solve a rational equation, we want to determine the value or values of the variable that results in an undefined rational expression in the rational equation. In other words, what makes each denominator 0 and exclude those values. Determine the LCD for all the denominators. Multiply each term by the LCD and simplify the expressions on each side of the equation. solve the resulting equation, and then check your solutions. All right, so let's solve some more rational equations then. Okay, now we have x plus 5 and x minus 5, x squared minus 25. That is a difference of two squares. So that factors as x minus 5 and x plus 5. Now, what values of x make one or more denominators 0? Well, here, if x is negative 5, then that would make that first fraction 0, the first denominator 0. Here, if x is equal to 5, it would make this denominator 0. So x cannot equal negative 5 or 5 for this. Okay. So now my LCD then is x minus 5 and x plus 5. So we're going to multiply every single term by the LCD. And again, I'll rewrite that as x minus 5 and x plus 5. Okay, the x plus 5's divide out. X minus 5 times 1 is x minus 5. X plus 5's divide out, so the x minus 5, so that leaves us with 2x. Here the x minus 5's divide out, so it's minus 3 times a quantity x plus 5. So again, by multiplying by the LCD, it gets rid of all our fractions and makes the equation easier to solve. So distribute. Combine like terms. And now solve. So I'm going to add x. Add 5. And then divide by 2. So we get x equal to negative 5. Now, the problem is one of our restrictions tells me that x cannot equal negative 5. So this is not an acceptable solution. So we have a no solution here. Okay, so let's take a look at the next example then. So now again, let's factor each of the denominators, because once we do that, we'll be able to figure out our restrictions quickly, and then we'll be able to figure out our LCD quickly also. Okay, so I'm going to write out the LCD first. Okay. So the LCD is y plus 3 times y minus 3 times y plus 4. Now, once you know the LCD, it's very easy to determine our restrictions. If one of the factors is y plus 3, then we know y can't equal negative 3. If one of the factors is y minus 3, then we know y can't equal 3. And when you have y plus 4, we know y cannot equal negative 4. So in this particular problem, we actually have 3 restrictions. Okay, so I'm going to multiply every single term by the LCD. Okay, so I've written this out again, and I've written the denominator in factored form, so it's easy to tell what factors are going to divide out. So for the first term, the y plus 4's and the y minus 3's divide out. So I'm left with 7 times the quantity y plus 3. Here, y plus 4 divides out, and y plus 3 divide out. So I'm left with minus 4y times y minus 3. Here, the y minus 3's and the y plus 3's divide out. So I'm left with 6 times the quantity y plus 4. Distribute. Combine like terms. Now, I'm going to move everything over to the right-hand side, so I'll start by putting the 4y squared over. Next, I'll subtract the 19y. And then I'll subtract the 21. Remember, it's a quadratic equation, so I want to set it equal to 0. There's no greatest common factor to factor out, so I want factors of 12, whose sum is negative 13. Well, that's negative 12 and negative 1. So let's rewrite negative 13y. I'll write it as minus 12y and minus y. Okay, we will group. The first two terms, I can factor out a 4y. The last two terms, I can only factor out a negative 1. Factor again. And then set each factor that contains a variable equal to 0. Now, let's go back to our restrictions. Our restrictions are 3, negative 3, and negative 4. So we know that is not going to be an acceptable solution. So the only solution that is going to work here is 1/4.